Hi, now we are going to see how to implement FSM in Verilog. Here we are going to take an example of a pattern detector. We are going to implement that using Verilog code. Generally, there are two types of FSM. One is Mealy, another one is More. The difference between Mealy and More is in Mealy, the output is depends on present state and present input. But in More, the output is depends on present state only. Okay, this Mealy and More again we can classify into two types as overlapping and non-overlapping. Okay, for example, 1010 will can take this pattern. We need to detect this pattern. This pattern we should detect in the given sequence of input. For example, the sequence of input is 10 10 10 10 0 0 1. Okay, let's assume this is the input pattern. Okay, the difference between overlapping and non-overlapping is if it is a non-overlapping in the given sequence 1 0 1 0 1 0 1 0, here it is directed. One time the pattern is directed. Okay, again it will check freshly 1 0 1 0. Again this pattern is directed. So two times it got directed. Again we don't have this pattern 1 0 1 0. Okay, this is for non-overlapping. If it is a overlapping, take the same pattern. Here the given pattern 1 0 1 0 is directed. The first time it got directed. Again this 1 0 1 0. This 1 0 is common for the first sequence and it is common for the second pattern which is directed 1 0 1 0. Again second time it is directed. Again it will check. Here it will consider from here 1 0 1 0. Okay. So this 1 0 is common for this one and as well as this sequence 1 0 1 0. So three times it's got directed here. So this is called overlapping. This 1 0 is overlap for this pattern direction and also for this pattern direction. Overlapping. Okay, now we are going to implement Mealy overlapping pattern direction. So we are going to detect this pattern 1 0 1 0 in the given sequence. Before that, we need to draw this state diagram. Then it will be very easy to implement in the design. Okay, first, we will implement the state diagram. We are going to implement this one overlapping pattern direction for this to detect this pattern 1 0 1 0. So here in Mealy, the number of states required is number of bits present in this pattern. So 4 states we need. Next we will take the 4th state. We will name this state. First state is S0. This is S1. This is S2. And this is S3. The 4 bits are there in this pattern. So we need 4 states to detect that pattern in Mealy. We are going to implement in Mealy. Now, first we will draw for this given pattern. When we receive 1, we have to move from S0 to S1. When we are receiving 1, we need to move from S0 to S1. At the time output is 0. And next 0. Assume that we are in S1 state. Next input we receive 0. We need to move from S1 to S2. Right, if we receive input 0, we are moving to S1 to S2. At the time also the output is 0. Then we are receiving third input 1. And the input is 1. Assume that we are in S2 state. When the input is 1, we need to move from S2 to S3. At the time output is 0. Here I write the values. This is just for understanding purpose. If I receive 1 as an input, I will be in this state. When I receive 1, 0, I will be in this state. When I receive 1, 0, 1. Okay. Now I will be in S3 state. After that, if I am getting 0, okay, pattern is detected. 1, 0, 1. Again, if I get 0, assume that I am in this state, S3. If I am getting 0, the pattern is detected. Okay, here I am going to implement overlap. Here, 1, 0, 1. After that, I am receiving 0. The pattern is detected. So, where I need to move is overlapping. So, this 1, 0 will be overlap for the next sequence. So, where is this present? It is nothing but yes, in S2 state. Okay. So, I need to move to S2 when the input is 0, 0. At the time my output is 1. Now I draw for the actual given pattern. Then we need to draw for the alternative possibility. Here we are going to draw for the overlapping. If it is a non-overlapping, when this pattern is detected, I need to move to S0 state. Again I need to start from freshly. Now we will check for the another possibility. S0. Assume that I am in S0. Okay. Instead of this one, if I get 0, I need to be in the same state. For input 0, output is 0. Assume that I am getting 1 as an input. Now I am in S1 state. Okay. Instead of this 0, if I get 1, I need to be in the same state. In this one, output is 0. Assume that I am in S2. If I get 1, I will move to S3. Instead of this, if I get 0, mean 1, 0, after that, if I am getting 0, okay, this pattern is not in this sequence, 1, 0, 0. So it is not helpful to proceed further. So I need to check again from the starting. I need to go to the initial state. Then I need to check from starting itself. Instead of 1, if I get 0, I need to move to S0. At the time, output is 0. Now, assume that I am in S3. I received 1, 0, 1. After that, if I get 0, I will move to S2. At the time, output is 1. Instead of this, if I get 1, 1, 0, 1. After that, if I get 1, instead of this 0, now I am getting 1 means from here to where I need to move. This pattern is not in the given one, right? Okay. So again it will start to count 1, 0, 1. Instead of 0, I am getting 1. So this one, it will check where it is checking in S1 step. Again, if I get 0, it will move here. If I get 1, it will move here. If I get 0, it will move to S0 again. Instead of 0, if I get 1, where is this 1 present? It is in S1. So again, the state will move to S1 for the input 1. At the time, output is 0. Now we draw the FSM. Let's check both are same. So we are getting this FSM now. Out this one is this one. So we move to S1, S2 to S1. So now we draw the FSM. The next thing is we need to implement the code. The right side, we implement the FSM here. So take the diagram. So now module name, inputs are for some we need clock, right? So the sequence is output. Clock data in, there's a single bit by bit we are going to receive from the test bench. Then pattern detect is nothing but the output. When 1010 is detected, this pattern detect will come on. Then reset is the input. So we declare the inputs and outputs. Here we are using two registers. Okay. We declare this present state and next state as a register to point out the present state and next state. Okay. Here actually we have 4 states that we declared as a parameter S0 0. 4 state to represent the state name. We are using values. S0 is nothing but 0, then S1 is nothing but 1, S2 is 2, S3 is 3. To store the value 3, maximum value 3, we need 2 bits. So the state we declared as which 1 is 0. To store the maximum value of 3. Then here at line number 11, at passage of clock, we are checking reset. Reset is 1. The present state and next state will move to, will point out the S0 state, the initial state. Then here is pattern detect is 0, output is 0 here. And in the case, we are checking the present state. If present state is S0, we are checking the data in input. If data in equal to 0, What is the next state? Next state is also S naught that we are mentioning. NS equal to S naught. Else, that means data in is 1 means we need to move S1. Next state should point to S1. So NS equal to S1. Here, from line number 7 to 10, another procedural block, we are checking always at NS. Wherever NS change, okay, automatically this block present state equal to NS. Next state will assign for present state. Each time when we changes the next state, this block will execute. It will assign next state and present state both are same. Here, assume that present state is S naught. We are checking data in. If it is 1, next state is S1. So by using this block, then NS, that is S1 will be assigned for PS. So next time at passage of clock, PS is nothing but S1. So it will choose this alternative S1. Here again we are checking data in value. If it is 0, it will move to S2. So NS equal to S2. Else, next state will be S1 itself. The same way we check. If next state varies, again this due to this PS equal to NS, the next state will be assigned for present state. Again, the present state changes, we'll choose another alternative, and next state will be assigned here. The same way it will do for all these state changes. Finally, if we reach S3, we are checking for data in. If data in is 0, next state is nothing but S1, and we should make the pattern detect as 1. This is the output. So we are making pattern detect as 1. Else, next state is S1. So we are moving to S1. If it is not 0, data in is not 0, we are moving to S1. So this way we can design this Mealy pattern detection. Then we will see the test bench for this. In test bench part, the input are declared as reach, the output declared as wire, which A is a 11-bit vector. We are storing this 11-bit. At each passage of clock, we are going to send this as a data in to the design. Here we instantiated the model pattern detect as a DUT. Here we generated the clock. Clock is 0, and as file clock equal to not off clock. Then we are applying reset. Then after 50 time units, we are releasing the reset. Reset will make it 0. Here, this initial clock, we are waiting for reset. So we need to send the data in after reset is released. That means after we make reset as 0, then we need to perform. So at leg edge of reset, that means when reset becomes 0, here at each passage of clock, we are taking A of I in this for loop. A of I is assigned to data in. First iteration A of 0, nothing but this value 1 will be assigned for data in. Next cycle, next iteration A of 1, that is this 0 will assign for data in. The same way will run for 12 times, 11 times actually. Each time we are displaying the data in value here. Then in this procedural block, always at passage of pattern detect. The pattern detect is nothing but output. In test bench we are receiving that as an input. So each time when this pattern is detected, we are just increment DET value, the detect. So to show how many times the pattern is detected in the given sequence, then we are displaying that one. So we'll run and check this. The clock reset, we are applying reset, then after 5 cycles we are releasing, we are making reset as 0, then we are forcing data in one by one from the A vector, then this is the present state and next state. So when 0, we are giving data 1, 0, 1, 0, given pattern is that one. Okay, if it is detected, the pattern detect become 1. Okay, again it is overlapping, right? So 1, 0, 1, 0. Again pattern is detected. Again 1, 0, 1, 0. Third time it is detected. The given sequence, you see 1, 0, 1, 0. One time it will detect. Again 1, 0, 1, 0. Second time, then 1, 0, 1, 0. 3 times you are getting the pattern 1, 0, 1, 0. So each time when we get direct value get implemented. Then next, the same thing we are going to implement in more. Here, the number of state required is the number of bit in the given pattern plus 1. So here actually this is a 4. So we need 5 states to implement it. First, we need to draw for the given pattern. First, you draw the state. We actually get this 4 bit. We need 5 states to implement that in more. So draw 5 states. Okay. Here, in more, the output is depends on present state only. Okay. So along with this state, we need to mention the output. A it is 0, B it is 0, C it is 0, D it is 0, E here it is 1. So when the pattern is detected, draw this 1. So first draw for the given pattern. When we receive 1, we should move in B. Okay. Assume that we are in B. The next sequence of input, if we receive 0, we need to move to C. From C, if we are getting 1, we need to move for D. After that, if we get 0, we need to move for E. Then from E, again, if we get 0, okay, if we get 0, so this is not, it's a overlapping, but if we get 0, it is not as it's going to help furtherly direct this sequence. Okay. So we need to start from initial. 0 means it will move to here, initial state, again it will start checking. 0 again is check for 1. Then it will move to state. So for 0 we are moving here. In case if you are getting 1, 1 means already we have 1 0, again 1 we get 0, again a pattern will be detected. So after this, if we receive 1, it's overlapping. So this 1 0 1, where it will be present in this state. So it will move here. I will explain with the diagram. One zero, we need to detect. We are going to use more model. The number of states required is 5. So name this state. Here we can take as A. Here we can also mention the corresponding output for each state. The output is depends on present state. Now the input is 1 to move to B. From here the input is 0 to move to C. From here the input is 1 to move to E. 1 0 1. Again the input is 0 to move to D. At the time output is 1. Okay. Just write this value for understanding purpose. If we get 1, we are in this state. If we get 1 0, we are in this state. If we get 1 0 1, we are in E state. Here 1 0 1 0 means we are in D state. After this, if we get 0 means this pattern is not the sequence of the actual pattern. So we need to check from the starting. Okay, when the input is 0. In case if the input is 1, okay, 1 0 1 0, again we will get 1. So this pattern previously where it is available 1 0 1 is available here. So it will move here for the input 1. Again after this if we get 0 it will move here. Again the pattern is directed 1 0 1 0. Now we will draw for the alternative possibility. Assume that we are in state A. Now we need to, if we are receiving 0 instead of this one, we will be in the same state. Assume that we are in B. Instead of this 0, if we get 1, again here the state where is 1, so we will be in the same state. Assume that now we are in C. 1 0. After this, if we get 1, we are moving to B. Instead of this 0, we are receiving, instead of this 1, we are receiving 0. Okay. I mean 1 0. After that also we are receiving 0. So this sequence will not helpful to proceed further to check this pattern. Okay. So again it will check from the starting for the input 0. Again it will check for 1. If it is 1, it will move here. If it is 0, then it will move here. If it is 1, it will move here. Assume that we are in this E state. That means we are receiving this 1 0 1. If it is next input is 0, we are moving to D. Else, if, instead of this 0, we receive 1. Okay, where we need to move? Okay, again, we need to check. Okay, first one is detector. Okay, where it is 1, D. The state is 1. So we need to move to B and it will check the consecutive values. If we receive 1, it will move here. Again it check for 0. If it is 0, it will come here. Again it is 1, it will come. Again it will 0. It will receive 0. Again we can detect the pattern. So this is for 1. Okay, now we draw the more overlapping model. Now we need to write the Verilog code for this side. This diagram. Extend this code. It is similar to Mealy implementation. Here we have one difference from line number 11 to 70. Remaining all are same. Input, output, and declarations are there. Then here we have five states. Earlier we have four. Here we have five states. To represent that five state means maximum value is 4. A is 0, B is 1, C is 2, D 3, and E is 4. Okay, to represent 4, we need 3 bits. So the present state and next state is declared as a 2 is to 0, as a 3 bit. Then always at passage of clock, if it is reset, present state and next state pointing to the starting state A. Then when not a reset, pattern detect is 0. Based on the present state, we will choose the alternative and we are checking for the input. Based on the input, it will move to the next state. Next state will be assigned. Okay, when next state changes, here line number 8, each time when next state varies, we are assigning the next state to present state. Then based on that, here it will select the next state. Here, moreover, the output is depends on the present state only. So here, from line number 11 to 17, we implement that concept. If present state is A, output is 0. Pattern detector is 0. Only when the present state is D, not D, it is E. So automatically else part. In line number 16, else part. When none of these are satisfied, the present state is E means it will move to this else part. At the time, pattern detect become 1. That is the implementation of this more FSM. And testament portion is similar to Mealy. Here, the testament we are going to force or drive the clock reset and the inputs data here. In bridge A, we are storing the values, and one by one we are forcing here to the data. We are assigning to data. Here, clock reset. After reset is released, we are driving the inputs. So the pattern is detected. Here, after 1, 0, 1, 0, we detected one time. It is overlapping again for 1, 0, 1, 0 is detected here. Again 1, 0, 1, 0 is detected 3 times. Based on the pattern detect, we are receiving the test bench. We are implementing detect. So this also get implemented. We are getting the test 3. Okay, remaining we'll see later.